Lesson 9.2 is on solving quadratic equations by graphing. In this lesson, you'll learn to solve quadratic equations by graphing and estimate solutions of quadratic solutions by graphing. Vocabulary is just double root. Okay, so there's three different types of graphs that's going to give us three different types of solutions. So if you have a graph where the graph touches the x-axis twice, that means there's two solutions. If, like in the center case here, it only touches that one time, that's the vertex is on the x-axis, then there's only one solution. And if it's above or below the x-axis and doesn't touch it at all, then that means there's no real solution to the quadratic equation. So we want to look at this and figure out the solutions by looking at the graph. So in order to do this, I'm going to start by graphing it like we were doing in the last section. So I'm going to find my vertex to start. So that's going to be, I'm going to start by doing negative b over 2a. So when I do that, my negative 3 is going to be 3, and 2 times 1, so I get 3 over 2. Okay, so that's going to give me the x-coordinate, 3 over 2. And I need to know the y. So to figure out what y is, I'm going to plug in 3 over 2 into my equation for y. So when I do that, you can use your calculator to do that. I get negative 12.25. Okay, so that's going to be my vertex, and from there it's going to be opening up. So I want to have at least 12 boxes below, or 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Wait, okay. So I'm going to draw my axes here. This. Okay, so I have the point 3 over 2, so that's 1.5, and then it goes down 12.25. So that's going to be about there. Okay, and then I want to find another point, so I can find my y-intercept. My y-intercept is going to be this number here, right? So at negative 10. So I go down to negative 10. And because this is symmetric, then I'm going to have a point right along this. Okay, so if I have a point there, the same distance, but on the line is going to be here. So far I have that. And then I want to find a few extra points. So let's make a table of values. And let's say I do x and y. I'm going to put in like negative 2. And when I put in negative 2 into my function, I get 0. Oh, man. Didn't want to do that one. Okay, so negative 2, 0 is that point right there. So same distance. This is 1, 2, 3.5 spots away. So we're going to go 1/2, 1, 2, 3, and we're going to have this point here. So I can graph this. Hopefully you guys can draw better than I can. We get about this shape. So the solutions are where it touches the x-axis. So in our case here and here. So we just said negative 2 is one of them. And this one is the point 1, 2, 3, 4, 5. So negative 2 and 5 are our solutions. Those are the values of x that are going to make this true. Okay, so we want to do this one too. So I'm going to start by moving that 16 over. So x squared plus 18x plus 16 equals 0. And this is what I want to graph. So again, I'm going to do negative b over 2a to find the vertex, and I'm going to plug that in. So I'm going to do that right now. I get that the x-coordinate is negative 4. So I plug in negative 4 for x into this equation up here above it to find the y value of the vertex. When I do that, I get 0. So my vertex is the point negative 4, 0. So because our vertex is right here, that means it's either going to be going up from there or down. But it's not going to touch it at any point. So once you get like that point, you can say that x equals -4 is a solution to this. If you put a -4 into this equation, it's going to work. But let's just get a few more points so we can get an idea of what this is going to look like. So our axis is the vertex, that's going to be along this line here. And then we want to find the y-intercept. So the y-intercept is going to be at 16. So symmetric, there's going to be another point like over here, and so our graph is going to come and do, whoops, something like that, more or less. Okay, so we see that there's only one solution where it touches the x-axis, which is at -4. Okay, we want to graph this one, so we're going to do the same thing. We're going to do -b over 2a, and then I'm going to plug that in. So I'm going to do that really quick right now. Okay, so when I did -b over 2a, I got -1, and that makes it the x coordinate, and we plug that in for x, and when I did that, I got 2. So my vertex is the point -1, 2. If that's the vertex, the axis of symmetry is right along here, so that it's going to be symmetric on either side of it. We can graph the point 0, 3 because that's going to be the y-intercept. So if I have the point 0, 3 that's here, and because it's symmetric, there's going to be another point also right there. So you can see that this is the vertex that's going to be coming and doing something like this. So this graph here, that black line is never going to touch the x-axis, which means there's going to be no real roots. So roots is another thing for 0, or when it touches the x-intercept, or touches the x-axis, so x-intercept, root, 0, or solution, they all mean the same thing. Okay? Okay, example 4, we want to graph this one as well. So we're going to start by finding our vertex, -b over 2a to start, and then we're going to plug that in. Okay, so doing -b over 2a, I get 2, and that's the x coordinate, and I plug it in for x, and I get -2 for y. So that means my vertex is at 2, -2, right here. And symmetry is going to be along here, so any point I get on one side, I can reflect to the other side and have less points to have to plug in. So let's start with our y-intercept. Right, that's always the C value. So there's going to be a point here. That's 2 away from that line, so 2 away on the other side brings us to there. If I put in 1, let's make a table of values, x and y, because if, so let's put in 1. So when I do this, if I put 1 into my function, I'm going to get -1 for y. So I get the point 1, -1, which is there, which means there's going to be another one right there. And every integer I've put in now, I put in 0, 1, 2, 3, and 4, which means that our answer, because I still haven't touched the x-axis with any of those points, my answer is going to be a decimal. So I want to come up with a way to estimate what exactly those x-intercepts are, where it's touching the x-axis. Okay, so what I'm going to do is I'm going to plug in a bunch of decimals. So we can see that from the graph that it's between 0 and 1 and then between 3 and 4. So I'm going to make a table of values and I'm going to do all the decimals between 0 and 1. So 0.0, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. And then I'm going to do the ones between 3 and 4, 3.1, 3.2, 3.3, 3.4, etc. Right? And I want to plug all those things in. You can do this using a calculator because it's difficult to do this many by hand. So if you're using a calculator, you can do that. So I'm looking to see when it switches from negative to positive. Okay, so these are all positive answers, and then all of a sudden they're negative. That means it's crossed over the x-axis. You went from positive to negative. So somewhere in this region, it switches. So I want to know, is this number closer to 0 or is this number closer to 0? And we see that this one here is closer to 0. So that means that 0.6 is a good estimate, 0.6. It's not exact, but it's a good estimate of one of the x-intercepts. And then I want to do the same thing with the other one. These are all negatives, and then it switches to positive. So when it switches, the positive one and the negative one, I want to see which one is closer to 0. And again, this one here is closer to 0, so that means 3.4 is a good estimate for the other x-intercept. Okay, so that's the solution, 0.6, x equals 0.6, and x equals 3.4. Okay, the next one I want to show you how you can approximate roots with a calculator. So Consuela built a model rocket for her science project. The equation h equals negative 16t squared plus 250t models the flight of a rocket launched from ground level at velocity 200 feet per second, where h is the height of the rocket in feet after t seconds. Approximately how long will Consuela's rocket be in the air? Okay, so if we're looking for how long it's going to be in the air, we're looking for the final height. We want to know when it's going to hit the ground again. So our height would be 0. So we want to know when this thing, negative 16t squared plus 250t, is equal to 0. And this is what we're going to use a calculator to solve. So we're going to switch over to a calculator online. We're going to use Desmos. Okay, so what I did is I took the equation that we had, negative 16t squared plus 250t, and I typed it into Desmos, okay? So you type it in as y equals that thing, and you get the shape of the graph. Okay, you might need to play around with the zoom a little bit, and you can do that by clicking this little toolbar here, and you can change this. You can also do it by zooming in and out, but that might be difficult with really big numbers. So if you first put this in and you don't see the graph at all, try and change your settings to make it bigger, because this is going from 0 all the way up to nearly 1,000, and then from 0 to 15. So I think it starts out from 10 to 10, negative 10 to positive 10 in both x and y. So you need to change those a little bit. But now I can look at this and I can try and figure out how long this thing was in the air. So if it starts at ground, this represents time on this axis, and this represents the height that the rocket went. So it goes up in the air, it goes up, 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 and then after time it starts coming back down. And it hits the ground here. So I'm going to look at this and say, okay, well, what does that look like? And you can look at the graph and say that's about 15.6-ish. I don't know, let's see, 1, 2, 3, 4, 5 boxes, so 3/5, so about 6. Okay, so you can say that this is approximately in the air for about 15.6 seconds. Okay, and you can do this with your graphing calculators. You can zoom in and out and look at the graph and see about where it touches. You can also use the method we did with the last one with the table and to get it a little bit more accurate. But for the sake of this class, if you can get it pretty close, that's okay with me by zooming in on your calculator. Okay, and that's the end of this section. If you have any questions, we'll go over them in class.